Hello and welcome to yet another South Korean College Scholastic Ability Test video. Today we are going to solve the following problem. So we are given with 5 curves on the complex plane. Among the following curves on the complex plane, for any points P corresponding to complex number Z1 and Q corresponding to complex number Z2 on the curve, which curve is impossible for the complex number Z1 over Z2 to become a purely imaginary number. That is, a number in the form of bi, where b is a real number and I is the imaginary unit. Alright, let's get right on to this problem. So the given condition is this. In 4 out of 5 given choices, Z1 over Z2 is a purely imaginary number bi, and we have to find a choice where this is impossible. In order to use this condition smartly, you need to know about some properties about complex numbers, and the first thing you need to know is the polar form of complex numbers. Consider point P on the complex plane representing the complex number Z. Z has a real part A and an imaginary part B, hence it can be expressed as A plus bi. However, there is another way to express this complex number. The same point P can be uniquely determined by specifying these two variables r and theta, where r is the distance from origin O to point P, and theta is the angle between the half-line OP and the positive direction of the real number axis. Here, r is called the absolute value of complex number Z, and theta is called the argument of Z. Then you can easily realize that the real part A and the imaginary part B can be expressed like these. So the complex number Z can be expressed as r times cosine theta plus I sine theta. This is called the polar form of the complex number. And regarding this polar form, you need to know one more property, which has to do with the multiplication and division of complex numbers using the polar form. Consider these two complex numbers given in a polar form, Z1 as R1 times cosine theta 1 plus I sine theta 1, and Z2 as R2 times cosine theta 2 plus I sine theta 2. Then it can be easily shown that the product Z1 Z2 is equal to R1 R2 times cosine theta 1 plus theta 2 plus I sine theta 1 plus theta 2, and the quotient Z1 over Z2 is equal to R1 over R2 times cosine theta 1 minus theta 2 plus I sine theta 1 minus theta 2. You can easily prove this using angle addition formulas from trigonometry. From these, we can obtain these important results. The first one is, of course, when two complex numbers are multiplied, their absolute values are also multiplied. And the second one is that when two complex numbers are multiplied, their arguments are being added or subtracted in case of division. And among these, let us focus on this subtraction property of arguments. If these two complex numbers Z1 and Z2 have arguments theta 1 and theta 2 respectively, then the argument of Z1 over Z2 is equal to theta 1 minus theta 2. But theta 1 minus theta 2 is the measure of this angle right here. So it is equal to the angle POQ. With this in mind, let us take a look at the given condition that Z1 over Z2 can be the pure imaginary number bi except one of the 5 choices. This means that the argument of Z1 over Z2 equals the argument of bi. But on the complex plane, points corresponding to imaginary numbers bi can exist only on the vertical axis, the imaginary axis. This means that the argument of bi can be only odd number multiples of pi over 2, or plus minus 90 degrees if you want to confine the argument between negative 180 degrees and positive 180 degrees. Now this is the possible argument value for imaginary number bi, but the geometric meaning of the left-hand side is that it represents the measure of the angle POQ. Therefore, This means that the measure of angle POQ must be 90 degrees. And this is the criterion that we are going to use to find the answer. So the main question, which curve is impossible for z1 over z2 to become a purely imaginary number bi, can be also expressed like this. In which case can angle POQ not be the right angle? This means that if we can find a single case such that angle POQ is a right angle, then that choice cannot be the answer and thus can be discarded. So let's take a look at these cases one by one. In choice number 1, we have a horizontal line. Here, we can easily notice that if we take points P and Q like this, then angle POQ can be 90 degrees. Therefore, choice 1 cannot be the answer. And choice 2 is even easier, because we can find the right angle case almost right away. So choice 2 is also not the answer. And choices 3 and 4 shouldn't be difficult either. In choice 3, we have this example of angle POQ being 90 degrees, and in choice 4, we have this example of angle POQ being 90 degrees. So both choices 3 and 4 cannot be the answer. However, if we get to choice 5, then we have a different story. Here, the graph only exists in what can be considered as the first quadrant and the third quadrant. And that fact leads to the following result. If we choose points P and Q from the same quadrant, that is, the same branch of the graph, then angle POQ is always less than 90 degrees. On the other hand, if we choose P and Q from different quadrants, from different branches of the graph, then angle POQ is always greater than 90 degrees. In any cases, angle POQ becoming the right angle is impossible. Therefore, the answer is choice 5. And that's all for today's video. Thank you all for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.